Alright, chemists. So today we're going to talk about, well, last lesson we talked about particles, and this lesson we're going to talk about what those particles are made of, or our model for those particles. So what's the point? Basically, you want to be able to describe our model of the atom in several different ways. You want to be able to do it with pictures. You want to be able to explain them. You also want to be able to do it with numbers, and you want to be able to use a couple of the very basic numbers like the atomic mass and the atomic number to identify the atom. And by doing this, we need to be able to use those numbers to work out the structure of the atom. Alright, so here is our model of carbon. Okay, now it's not entirely clear because they've gone for the 3D look as opposed to a straight up, these are all the circles next to each other, but there are 6 protons and 6 neutrons inside this part of the atom, which, I'm never going to get that pen, just get the pen, which we will call, we'll put a little N there, and that's the nucleus. Okay, so that's the nucleus of the atom, and that's actually much smaller than the rest of the atom, but that's the smallest part of the atom. But it is the heaviest. Okay, so we've got 6 protons, 6 neutrons in there, and what you'll see floating around is we have 6 electrons. Okay, so those are 3 subatomic particles. They're called subatomic because they're smaller than the atom, and the atom is made up of those 3 particles. So we've got a proton, which has a mass unit of 1. Now, atoms weigh such a small, or have such a small mass that we came up with this other unit called AMU, atomic mass unit. Alright, so a proton has a mass unit of roughly 1. A neutron also has a mass unit of roughly 1. An electron, it has a mass unit that is so small that for now we can essentially ignore it. We don't need to worry about it. It's not a drama. But what you will notice is that it is roughly the difference between these 2 numbers here. Okay, and that's actually quite interesting. It's almost like the reason it's not exactly the same as that is a rounding error, and that comes down to nuclear physics later on when we talk about beta radiation. Anyway, I digress. So, proton, neutrons both have a mass unit of 1, whereas an electron is much smaller, 0.0005. Okay, now, charge, neutron, neutral. So that's fairly easy to remember. Electrons, however, have a charge of -1. Protons have an electrical charge of +1. This becomes very important when we start looking at the way chemical bonding happens. Okay, where are they found? Nucleus, nucleus, orbital. So this means around the outside. Alright, these are the symbols we're going to see on our periodic table. Okay, so we've got the atomic number here. Alright, that is the number of protons and electrons. Alright, we have the mass number. Well, here's the symbol and the name. Okay, we have the mass number, and it's the number of protons plus neutrons in the nucleus. Now this one's 74, it's a nice round number, but if we move over here, no, that's not going to do it for us either. Okay, so the atomic number is the number of protons and the number of electrons. Protons and electrons are the same, generally, unless we're talking about ions, and it's the protons which define the atom. So if an atom has 11 protons, it's sodium. If an atom has 11 protons, it is always sodium. It's never anything different. Now, if we get down to here, we see that sodium has 12 neutrons. The atomic mass for this is 11 protons plus 12 neutrons. So if you want to know how many neutrons something has, you can go, what is the mass number minus the atomic number, and that will give you the number of neutrons. Alright, if you want to work out the atomic mass, but you know the number of protons and neutrons, you add them together, that gives you the atomic mass. So that's those 2 numbers and how they relate to, so that's how this number and this number relate to electrons, protons, neutrons. Alright, so how many electrons, neutrons, and protons are there in each of these three elements here? We'll start off with nitrogen because it's the smallest. One thing you know is that these are no longer whole numbers. They're averages. So this is the average atomic mass of nitrogen, the average atomic mass of cobalt, and the average atomic mass of barium. So you round these up or down to whole numbers and you work from there. So this one becomes 60, this one stays at 137, this one stays at 14. So nitrogen has 7 protons, 7 electrons, but it has 14 minus 7, which equals 7 neutrons. Okay, that's fairly straightforward. Cobalt has 27 protons, 27 electrons, but it has 27, also has 60 minus 27, which equals 33 neutrons. Okay, so that's how it is. We get there. Barium. Okay, barium's going to be a bit trickier. Barium gives us 56 protons, 56 electrons, and 137 minus 56, which gives us 8. That brings that down to 0. Which gives us 81 neutrons. Okay, so that's how we use those numbers to work that out. And that's our lesson for today. I'll see you in class or in the next video.